Hello everyone, welcome to the Mechanics of Materials, and here in this video we are going to introduce another section, another topic is called position vector. I believe position vector of most of you will have learned before. It is also a very quick review. And previously we introduced the force vector, and then here we introduce a position vector. Okay, as you know, in 3D space, in 3D space, when we want to describe the position of a point, for example, position of point, let me say position of point. For example, the right hand side, the position of point here is here. Yeah, be careful when you read the coordinate. Okay, x is here and y is here and z is here, and it's right hand rule. X cross y is equal to z. Okay, it's a right hand rule. X cross y and the z direction is up. And okay, here now, okay, let's say when you want to describe a point in 3D space, we use the three numbers: x coordinate, y coordinate, and z coordinate. X component, y component, z component. So here for this example, I think the position of A is 4. Okay, this is a 4. And x and y is 2, and z I think it's -6. And for b, okay, x is 2 and y I think y is 0. I think sorry, here very tiny, y is -1, here is -1. Yeah, -1, and z is 4. Okay, so this is a position of A and B, and then if you had a position of A and B, and we can define a position vector of OA and OB. Actually, the position vector is not only the position vector is not just a number. The position vector is a relation between the 2 points. Okay, because in our coordinate system we have always have origins called 0, 0, 0. Okay, 0, 0, 0. Okay, so the OA vector, well, position vector of B actually it is 2 minus 0 I plus minus 0 J plus 4 minus 0 K. And our position vector of A is actually 4 minus 0 I plus 2 minus 0 J and plus minus 6 minus K. Okay, but most often we just express 2I minus J plus 4K. And for this one is 4I plus 2J minus 6K. Okay, because we don't express a vector like this, because it look like a little awkward, so I just express position vector B and A like this. But actually, it's a relation between the 2 points. You need to know this because vector is a relation between the 2 points. Yeah, the position vector we write it in this way just because the reference point is 0, 0, 0. Okay, so that you don't sense is a relationship between 2 points, but actually is a relationship between the 2 points position vector. Okay, so actually that's what this slide want to say in this slide. Okay, position vector is a 2-point relation between the 2 points. That's a position vectors. Okay, so suppose this is very simple. Yes, just express if we want to calculate AB vector. Okay, AB vectors. Okay, point A to point B. Okay. For example, this slide just want to, if you calculate AB vector, you have 2 points, A and B. Okay, we want to calculate AB vectors is A to the B. Okay, for this point, well, this figure is A point to B, A to B. So you just just minus 2 point minus the coordinate of these 2 points. But be careful because A to B, so you have to XB minus XA I plus YB minus YA. AJ and plus ZB minus ZAK. Yeah, don't make a mistake here because A point to B, so the coordinate is A point to B, so it's coordinate of B minus coordinate of A, so also that's A to B. But reversely, if you want to calculate BA vector, so that will be the reverse. Is A XA, it will be XA minus B I plus YB minus YA minus YBJ minus ZA plus ZA minus ZBK. Okay. Okay, just remember the order. You cannot reverse the order as you want. Okay, you must know it's which direction is A to B or B to A. It's very important because this is not equal. It will have minus sign. Okay, this two BA vector and AB vector and BA vector is not equal. It will have minus sign in there. Okay, it will have minus sign. Okay, okay, so. Okay, let's start a very simple example. Okay, I think it's a very easy one. Is there a less rubber band is attached to point A and B as shown in this figure? Determine the length its direction measured from the A toward B. Okay, here the question give you, okay, you want to calculate a vector from A to the B. Okay, A toward B, that means A point to B. Okay, you want to calculate AB vector. Okay, you want to determine its length and its direction. Okay, the direction is just directional cosine. Okay, so you want to calculate AB vector. Okay, let's say, okay, but it give you the 2 points. Okay, 2 point. You want to calculate the vectors. Okay, and like I say, you want to calculate, like I say, you want to calculate vector. So AB vector, that means the coordinate of B minus the coordinate of A. Okay, if you give the 2 point AB, you want to calculate AB vector, the coordinate of A minus coordinate of B. Okay, so the next thing you have to identify what's the coordinate of B or coordinate of A. Or just say what's the position vector of B and position vector of A. Okay. 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 Yeah, if you know the coordinate of B, yeah, you just know the position vector of B directly. You know coordinate of A, you know the position vector of A. Okay, so what's the position vector of B? B, okay, that means the coordinate of B. Okay, so X, Y, Z is here. Be careful, X, Y, Z. So the point B, that's his coordinate, looks like X is -2. And it's very hard to see. So in the 3, okay, -2, -2, 2, 3. Okay, this is it. And what's the, okay, let's say it's X is 1, where is Y? I think it's wrong Y. Z is -3. Okay, so we have coordinate of B. So what's the position vector of B? Very easy, right? Just by plus 2J plus 3K. What's the position vector A? Okay, you know the you know coordinate of A, so you must know the position vector of A, J minus 3K. Okay, AB vector. Okay, coordinate of B, coordinate of A. So that just means AB vector is equal to RB minus RA. Okay, so you -2 minus 1 I plus 2 minus J plus 3 minus 3K. Okay, so what's the AB vector? So the AB vector is just -3I plus 2J plus 6K. Okay, so what is its magnitude? Is, okay, -3 square plus 2 square plus 6 square. Okay, what's the answer of this? Need to calculate 9. 9 plus 4 plus 36. Oh, it's equal to 7. Pretty good. And so we know this. Okay, so the vector is equal to the magnitude times the direction. So it's minus I plus 72J plus 6 over 7K. Actually, this is your, like I said, don't forget it. This is your unit vector. Okay, this is your unit vector of AB vector. Okay, and this unit vector, the first term is just your cosine alpha is, okay, cosine beta and cosine gamma. Okay, so after you get this information, yeah, you will have the alpha, beta, gamma finally. So I don't need to spend time on this calculation. Okay, if your cosine alpha, beta, gamma is correct, okay, that should be you should be have the answer. You shouldn't have problem to get the answers. Should be have the answer. Okay. So what's the answer? Oh, here. Okay, the first alpha is 115 degree. Okay, let me see, right? Okay, so beta is 73.4 degree. And the final one is, let me see, it's correct. Okay, 31.0 degree. Okay, the same. We just also use the 3D Cartesian vector and it's the unit vector. Okay, so, okay, so there's also some other examples to calculate the position vector on other slide, but I think you can try it yourself and I will update the answer on the PowerPoint and then you can check by yourself. Okay, we just make this video short and we'll see you in next video and bye bye. Okay, bye bye.